Okay, students. Now, this is what up to this we have discussed that intensity is maximum when they are closely packed. Intensity is minimum when they are loosely packed. Okay, right? Next, coming to next topic is next property is contract. They contract longitudinally. So, what is about longitudinally? If you take here the two charges here, which is present, one is positive, another is negative. Okay, right. Now, this charge is going to attract this charge in what direction? This direction. This is what type of direction? This longitudinal direction. Okay, right? This is longitudinal direction. So that this charge is going to attract this charge in what direction? This direction. So that all these electric lines of force are passing in what direction? This is the direction of electric lines of forces. These electric lines of force are always perpendicular to the charge carrying conductor. Okay, right? Understood, student? This is very important topic. So far we have discussed that these electric lines of force are starting from positive charge and end towards negative charge. Okay, understood? Next one. So they contract longitudinally. So longitudinally means what, ma? These lines of forces are going to be, that means what, ma? This positive charge is going to contract the negative charge like this. Like this. Okay, right? That means what? Here, this positive charge is going to attract the negative charge in what direction? This direction, like this. This direction. Okay, right? That means what? In what direction? Longitudinal direction. Okay. So what type of phenomenon takes place here? Attraction will takes place. Attraction will takes place. Okay. This is next property. What is this property? Contract these electric lines of forces. These electric lines of forces will contract longitudinally. Hence, we got attraction. Next coming to another topic, that is they exert lateral pressure. Lateral pressure. They exert lateral pressure. What is this lateral pressure they exert? How can they exert lateral pressure? So they exert. How can they exert lateral pressure? Now, according to a simple example for this, simple example is, if you take one positive charge and if you take one positive charge, what happens, ma? If you bring these two positive charges nearer, like this, then what happens, ma? These electric lines of forces are passing perpendicular like this. These lines of force are passing like this. Then what happens here? They may get contract. Na? So if you take two hands here, if you bringing like this, then if you make like this, these lines are moving, these electric lines of force are moving, contract, na? Yes or no? They are moving, contract. So that if you take the two charges here, if you take the two charges, which is positive and another is positive, then there is some repulsion will take place. Repulsion will take place. So that due to this repulsion, there is in between these two charges, there exerts some pressure here. There exerts some pressure. That is called as what, ma? Lateral pressure. There existing some lateral pressure, so that they exert some lateral pressure. Due to this lateral pressure, there is some repulsion will takes place. Repulsion will takes place. Okay, right? Understood, students? So last properties, these lines of forces, these electric lines of forces are going to exert lateral pressure. There is some pressure in between these two electric lines of force. Here also, they are exerting some pressure, lateral pressure. Okay, right? So far, again, we are going to discuss simple topic. This is 4-mark question or 2-mark question. This is very important question. Properties of electric lines of forces. So simply we have one trick that is what, ma? That is what, ma? Here simple trick is what, ma? S P I T I C E. This is very important code. If you know this code, then you can have 4 marks. Okay, right? You can have 4 marks. Spit, S-P-I-T-I-C-E. Spit ice. Now coming to first word. What is this first word? So what is going to be taking place? So we will discuss now. So properties of electric lines of forces. So if we have two charges, around the charge we have electric field. This is electric field lines. These electric field lines are passing away from this positive charge and coming towards the negative charge. We know that these electric field lines are passing away from this positive charge, and these electric field lines are passing perpendicular to the negative charge. These electric field lines are passing perpendicular to the electric charge, negative charge. Okay, right? So we have taken two positive. One is positive and another is negative charge. These electric lines of force are passing perpendicular. They start from positive charge and end towards negative charge. This is first property. They start from positive charge and end towards negative charge. What? Electric lines of forces. What? These electric lines of forces are starting from positive charge and end towards negative charge. Okay, right? Next, second property. All these electric lines of forces are perpendicular to the charge carrying conductor. These are charge carrying conductors. Okay, right? These are charge carrying conductors. So many examples we have. Okay, right? If you take a metal plate and if you attach with any tower like this. Okay, right? If you have a tower, cell phone tower, this is a cell phone tower. To this cell phone tower also, you have an antenna. For this antenna also, the electric lines of force are perpendicular like this. The electric lines of force are perpendicular like this. Okay, right? They never intersect. Understood, students? So these are conductors. These are conductors. For these conductors also, electric lines of force are perpendicular. Okay, right? Next. Now coming to third property. They never intersect. These any two electric lines of forces never intersect. Okay, right? Never intersect means what, ma? They will go in their own way only. They never intersect with another electric lines of forces. If they intersect means what happens? There is huge amount of disturbance will take place. Okay, right? If another electric lines are passing like this, then what happens? There is some disturbance will take place. Okay, right? Disturbance will take place, so that we are not going to receive the signals. Okay, right? If we are speaking in a phone, okay, why the phone the voice is not clarity? Why? Because of if the electric lines of forces are disturbing another electric field line, so that the voice clarity is different. It is not going to be clarity. Okay, right? Quality voice is not going to be taking place. Okay. Next, coming to they never intersect. Intersect never. Okay. Next, tangent drawn to the electric lines of forces give the direction of electric field at that point. If you draw one tangent at this point, this is a tangent at this point. We have drawn a tangent. This will give the electric field direction at this point. At this point, what is the direction of electric field? If you draw a tangent, this tangent will give the direction of electric field at that point. Here also we have taken a point. At this point we have drawn a tangent. This point will give, this tangential direction will give the direction of electric field at that point. Okay. Here also, if you draw one line here, this will give the electric field direction. This will give electric field direction. Correct? Understood, students? This is very, very important. Next, intensity is maximum when they are closely packed. Here at this region, all the electric field lines or forces are maximum. Why? Because they are closely packed. Closely packed. Here, if you take here at this point, loosely packed, so that intensity is minimum. Electric lines of force are minimum. Why? Because here only in this area only two electric lines of forces. If you take here, the electric lines of force are only one in this region. If you take here at this point, maximum, that means what, ma? Closely packed, so that the maximum intensity of electric lines of forces. Here also maximum. If you take here, loosely packed, so that minimum intensity of electric lines of forces will take place. Next, coming to contract. These electric lines of forces are contract longitudinally. That means what, ma? Between these two charges, one is positive, another is negative. The electric lines of force are starting from positive and then towards negative. Okay, right? So that this positive charge is going to attract the negative charge in what direction? This direction. This is longitudinal direction. This is what type of direction it is? Longitudinal direction. This is longitudinal direction. So that this positive charge is going to attract the negative charge in what direction? Longitudinal. Contract. They contract longitudinally. So that there is some attraction phenomena will take place. Next, coming to they exert lateral pressure between the two charges. If we take one is positive and another is negative, between these electric lines of forces, these positive charge, these electric lines of force are moving in this direction. This also positive charge, it is moving like this. In between these two electric lines of forces, there exerts a lateral pressure. Why? Because repulsion will take place. There is some lateral pressure will take place between the two charges. Okay, got it, ma? So this is very, very important topic. Be careful, it will give for 4 marks or 2 marks. Okay, right? If you have any doubts, Nana, please ask me. Thank you.